Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is depreciation. What we are going to learn today is how to find a derivative of some special functions that we call the parametric equation. So let's begin. After completing the very lesson today, my dear student will be able to find the derivative of parametric equations. This is what I hope you'll be able to do after completing the lesson today. So as usual in your favorite segment of the lesson, Mercy is fun. Today I want to tell you that this number one is so special. In fact, it's the only number that is loved by all. I'll tell you why this number is loved by all after completing my lesson today. So don't go away. To begin the lesson, let us first learn the rule that will guide us what to do in order to find the derivative of parametric equations. But before then, let us just learn what are parametric equations. These are nothing but two different equations. One of them y and the other one x. But both of them will now be functions of t, as you can just see y equals to f of t and x equals to g of t. The two functions y and x are both the functions of the t. It is this type of functions that we call parametric equations. And what you wanted to do is to find the dy by dx. This is the function y, which is in a t. And this is the function x, which is also in a t. And you want to find the derivative of the function y with respect to x, that is dy by dx. So let's learn what to do, what the rule will tell us to do. So if that is the case, derivative of the function y with respect to x, that is dy by dx, this is what the rule tells us to do, is nothing but y prime divided by x prime. Where, of course, you know what is y prime, is the derivative of the function y with respect to whatever letter there, so it is t. And x prime, you know what is x prime, is derivative of the function x with respect to whatever letter it contains there. So this is what the rule tells us to do. If we are to find the dy by dx, this is the function y, which is never in x, and this is the function x itself, which is never in y. So you ask to find the dy by dx, and this is what the rule tells us to do. You now find the y prime, that is derivative of the function y, and you also find the derivative of the function x, because the two are separate functions, and you now divide them. What you have after simplifying is the dy by dx of these parametric equations. So where, like I have said, your y prime is nothing but dy by dt, that is derivative of the function y. It is in terms of the t, so it is now dy dt, and the x prime is nothing but derivative of the function x, because x is in terms of t, so you now have x prime to be equals to dx dt. This is what we are going to use to find the derivative of these parametric equations. We are going to take examples, see how we can make use of this rule to find the dy by dx of parametric equations. So let's just move. Example number 1, you asked to find the dy by dx, but if you have the function y equals to t raised to the power of 3 and another separate function x as equals to x equals to 3 raised to the power of 2. These are parametric equations because I have a function y and function x, and the two functions are both the functions of t each. Solution to this very problem. So what we do first is to write down the formula for finding the derivative of this parametric equation, which says dy by dx equals to y prime divided by x prime. So what remains is to get to my y prime and to get to my x prime. Remember, y prime is a derivative of the function y with respect to t. Let me go ahead and find the y prime. This is the function y, and I'm finding this derivative with respect to t, and this is a derivative of t raised to the power of 3. That is now going to be 3t square if you do it correctly. Then I'll now find the x prime. This is the function x, which is in terms of t. So I'm finding derivative of this x with respect to t. And this is now going to be 2 times this 3 to get to 6. And the data power 2 now reduced to 2 power 1. So x prime is now going to be 6t. So there I will go back to this in my formula for parametric equation. I substitute my y prime and substitute my x prime. So there I continue. So there I'm now going to have y prime as 3t square. And my x prime, I'm going to have it as 60t. So replace the there. So I will now simplify this. You can see 3 can divide this very 6. Similarly, this t can divide this t square. So what I'm going to have 3 in 3, 1, 3 in 6, it will be 2. T in T1, T in T square, what you have in the end, it will now be just 1T. So there I'm going to have T over 2. And the 2 is a result of dividing 6 by 3. That gives you this 2. And this T you have as your numerator is a result of dividing T square by this T. And this is dy by dx of these parametric equations. So let's just take another example. Example number 2, you ask to find the dy by dx if you have the function y equals to sine 2t and another separate function x equals to minus 2 cos to 2t. Solution to this very problem. So looking at this as parametric equations and asked to find the dy by dx, so I'll now write the formula. Dy by dx, it says is nothing but y prime divided by x prime. So what I'm going to do is to find y prime and find x prime. So dy prime is derivative of the function y with respect to t. So derivative of sine 2t. Sine 2t, remember, that is going to be 2 cos to 2t. And I'll now find the x prime, that is derivative of the function x with respect to t. So I'm finding derivative of minus 2 cos 2t. Cos to 2t, remember derivative of cos is minus sine. But this is cos to 2t. So it's now going to be minus the 2 cos to 2t. But I have another minus 2 already outside. So this minus 2 outside will now multiply that minus 2 from the derivative. So it now changes to positive 4. So I'm going to have 4 sine 2t. This will now be the x prime. So I have my y prime, I have my x prime. So I'll go back to this, my formula, and substitute them correctly. So then I'm going to have as y prime 2 cos to 2t, and as my x prime, I'm going to have 4 sine 2t. So I'll look where I can simplify further. I'll do that. This 2 can divide this 4, but this 2 never cancel this 2. So it's only this and this that you can now simplify. So 2 in 2, 1, 2 in this 4 is now going to be 2. So you are going to have cos 2t over 2 sine 2t. This will now be the dy by dx of these parametric equations. So with this, just a few examples, I hope you'll be able to find the derivative of parametric equations. And this is what I'm going to stop in this very lesson today. Thank you for your attention. And let me just move to the last segment, Mars is fun, and tell you why this number 1 is loved by all. So interesting thing about this number 1. It says whether it is in academics or in the business or in the sports or any other contest, any other type of contest, people who love to be rated or ranked as number 1 or first. So 1 is loved by all. And this rating simply tells us that, or simply denotes that somebody that is rated number 1 or first is now superior over others. So what is the number loved by all? Thank you for your attention. We see more of these interesting things in mathematics in our subsequent